I'm going to talk through a couple concepts in .NET. One of them is this idea of garbage collection. So .NET has a feature called garbage collection, which essentially deallocates memory that is not being used. So whenever you have an object that exists on the heap that doesn't have a pointer on the stack, .NET is going to run an algorithm to say, okay, what objects do not have any references to them anymore, and I'm going to deallocate the memory to be then reallocated later on in the future in our application. This way, we don't have to perform this manually in the code, right? We don't have to say, deallocate, or we don't have to call these manual things to release the memory that we had just used for a variable. .NET should take care of this for us. But there's some considerations that we have to give when working with .NET and working in this garbage collection context. And I'm going to show you a couple examples that I think are going to kind of illustrate, just some considerations to give as you're working in .NET. So I have an API running, and this is just an Engines API. It's part of my system. This one is actually a early testing thing. I'm not actually using it in the system, but this is basically just like a scaffolded out API project in .NET, so there's nothing really happening. So I have this running, and I'm just going to call an endpoint to show you that it's pretty much nothing is actually occurring. You can see that. Sorry for the scale, but I just had to increase this so you can see in the video. You can see that like I'm returning fake data, so I'm not doing much. But I want to show you a couple things that apply regardless of what your API is doing, because it's really just the fundamental principle of checking for memory leaks and understanding garbage collection. That way you can think through your endpoints. So I'm gonna show you a couple commands that you can run to pull up some garbage collection statistics. You can pull up this in Visual Studio or Rider, but sometimes it's helpful to know the commands. That way you can pull this up regardless of what editor or IDE you might be using. So the first one here is you're going to want to install, this one here, you're going to want to install .NET Tool install and then -- global and .NET counters. Hold on, I'm in the way real fast. There we go. You're going to want to install this command first. And basically this is going to install a tool that's going to enable us to basically get an output of what our garbage collection statistics are. So go ahead and install that. And then once you've installed that, we're going to basically run this command here. So we're going to get the running processes that are on our machine, and we're going to go ahead and look for the process number for the Engines API that we have running here. So go ahead and get that number. For me, it's 9956. We're going to go ahead and copy that process number. Then you're going to come down here in Terminal again, and you're going to run this command right here. So you're going to say .NET counters, which is the tool we just installed, monitor, and then you're going to say give it a refresh interval. For me, I just did 1 second, but you can do it whatever you want. And then you will give it a process number. So for me, it's 9956. So I'm going to run that, and you can see that it's currently running in the background in this terminal window. So you can make this a new window. You can pull it up on the side as you're developing, but you can see that it gives us a lot of information here, which is very similar to what you would see inside of Visual Studio's diagnostic windows or Rider's monitoring. Rider's monitoring is pretty limited, at least in the Community Edition. You can get more advanced features in products they sell, but this gives you a lot, and that you can really use effectively. The thing we're going to be looking for is this garbage collection heap size. So this is basically going to show you, okay, how many megabytes do we have saved to the heap? And we will see in a second, so I'm going to move this back, and let's just, oh wow. Okay, there we go. I thought that was going to go crazy with the formatting. All right, so again, that's running in the background every second, and I'm going to go ahead and show you a couple endpoints um, that I'm going to call. So I'm going to move this down for right now. All right, so I had to come back and make an update to my code, but I'm going to show you the updates um, that I included in my endpoints. So I'm going to show you the endpoints that I have that I'm going to be calling, and I'm going to show you what the simulated behavior is going to be, right? So this is going to be, I'm going to show you a memory leak and how to fix the memory leak, but I'm going to show you how to see it with our monitor tool that we installed. Um, so I have a couple endpoints. One of them is going to be the string leak endpoint that I have calling this for loop here that's going to add to a string for every loop, and it's running it 50,000 times, so it's going to create 50,000 new strings. So in memory, so it's going to allocate all that onto the heap, and I'm going to show you what happens as this continually gets called, how it grows, and I'm going to show you another example using string builder and what the difference is going to be, what it looks like on the heap, and what our garbage collection does. So I'm going to show you this, and I have some running information here with the monitor tool. You can see a lot of data on this. So, I forgot to show you this. I also have an endpoint set up for collecting the garbage collection manually. So this is, we're going to call gc.collect. So I'm going to run this to show you, and then I'm going to explain after. So let's go ahead and I'm going to go ahead and actually call that garbage collection endpoint just to clear everything out of garbage collection. So let's go ahead and execute that. Make sure that we are, make sure that our heap size is small. And I'll explain what happened with these numbers in a second, but I want to make sure that my heap size is down before I call the string leak method here. Again, this is going to create 50,000 strings every time, or it's going to allocate 50,000 new strings into memory every time I call it. So we're going to execute that. We're going to see the heap size increase a little bit, but now it's a lot. So it spiked to 274 if you saw that. I'm going to call it again because garbage collection just ran. It kicks it down. As this is running, it's going to ramp up again the heap size. So 310 megabytes. I'm going to call this again just to simulate, it keeps getting called. Maybe we have multiple users. We have some running process that calls this, something in the background. We're going to keep calling it, and you can see how much the memory spikes on our garbage collection on the heap size. That's in megabytes. So if this was running quicker, if we were on a faster machine, you could see how that could very quickly spike exponentially depending on the number of users. And so the highest number that we saw in one of those examples was 310. You can see it kind of spiking. Again, garbage collection is running in the background, but that one spike there was over 800 megabytes. So we almost got to a gigabyte in data on our heap, which is a lot, which is crazy, and it's just me running this. So you can see that that's very clearly indicative of a memory leak, and we have to do something about it. So I am going to show you another endpoint after I call garbage collection. So if I'm going to call garbage collection manually, we're going to execute that. You'll see the heap size immediately drops because garbage collection took place. And the garbage collection, if you call it manually, that's a blocking operation for everything. Everything halts until garbage collection finishes. So you probably don't want to just call it manually unless you have a very good use case to do that. Now I'm going to do a string builder method, and I want you to pay attention to that same garbage collection heap size number, and I'm going to run this, and you'll see what happens. So I'm going to run it again, keep running it, You'll see it spikes. Okay, we got to about 14, 17 megabytes. Okay, but it's not having the big spikes like our other one did. It was spiking to hundreds and hundreds of megabytes, almost a gigabyte, which is crazy. So it's getting okay. It's getting to 20, um, 24, but it's not spiking like the other one. And so we probably could refactor that. We probably could um, work this a little bit. Like we shouldn't be maybe adding all the strings like in this loop. Maybe we can optimize this a little bit cleaner. But this is going to avoid us having to worry about very obvious memory leaks, right? So you can see that okay, it's still climbing. It's still 30, 34. So it still is climbing a little bit, but we're not seeing the same spikes as far as getting to 1 gigabyte in a random call because garbage collection hasn't called. Um, so I want you to see what's happening in on these numbers. You can see we're still sitting at 35. Garbage collection hasn't officially run yet. You can see we have Gen 0, Gen 1, Gen 2. And so what's happening is that in .NET you have a heap and a stack, basically. And a heap value types are stored on the stack. So that's any kind of primitive types, structs, and reference types are stored on the heap. So that's strings, classes, um, but the pointers to those reference types are stored on the stack. And .NET basically looks at the stack, determines which objects in the heap do not have a pointer to them, then deallocates them. You can do this manually yourself if you set an object to null, because you're effectively removing that pointer or the reference to that object. And then when you set it to null, it's a signal for garbage collection to deallocate that memory so it can be reallocated later. And so what's happening with this string here is that when we go to the string leak, this is the memory leak method here. What we're basically saying, because we're adding to a new string, what we're basically saying is that, okay, because strings are arrays of immutable characters, we're saying, okay, allocate me all this new memory to create a new string because we're not modifying the same string. We're creating a new string every time we're appending to it. So by appending engine dash 1 2 3 4 5, we're allocating that much more memory on our heap, and then therefore creating those pointers on the stack. The difference with string builder is it's not it's not doing that. We're not creating a new string every time, which is why we're not seeing that spike, because garbage collection doesn't have to go and try to figure out, okay, we've just created 50,000 new allocations of memory for these strings. We're not doing that with string builder. So if you're in a situation where you are in fact appending to a string, or you're modifying or working with strings inside of the context of a loop or something similar, go ahead and use string builder to avoid what you just saw as a memory leak. Um, and this .NET counter tool is very helpful. Like you saw that happen, but you can visualize like what's happening when you call garbage collection. Because if you look at the numbers, I'm going to execute garbage collection. You'll see these drop immediately on the heap size. So we've now ran garbage collection. We've deallocated memory that is not in use, and memory that is not in use is determined by a couple things. Basically, when objects go out of scope, they have no references, or when garbage collection is manually called. Um, and a couple things with heaps and stacks. So heap in .NET, there's a thing called managed heap, and there's a small object heap and a large object heap for objects greater than 85,000 bytes. And so what happens is that when you have an object that is allocated, so we've allocated this memory for a string, it's going to go to the small object heap if it's less than that threshold. And there's a couple things with that. So there's generation 0, 1, 2, and generation 0 is going to be like your local variables, right? Like your your variables inside your methods, your local variables. So those are going to be allocated and deallocated basically as fast as they go in and out of scope. You have a Gen 1, which is basically kind of your intermediary generation between 0 and 2. This kind of takes place after garbage collection happens. So you see here, we have a generation 1 size. You'll see after garbage collection happens, anything that's kind of remaining or lingering will get shifted over to generation 1. And then generation 2 above that is for long-lived objects. So like static variables or static classes will probably make its way to generation 2. And those don't get deallocated as much at all. They do get deallocated, but not nearly on the same frequency as generation 0. You can fine tune these properties actually if you go to, I'm going to expand this here. If you go to your CS proj, you can actually mess with these settings a little bit. One obvious setting you can switch is the server garbage collection. By default, that's false. You can set it to true and then see what happens. So if you were to set this to true inside of your CS proj property group here, you will see a little bit of a difference because a server garbage collection is going to be a little bit more, we'll call it obtrusive than a workstation garbage collection. So there's workstation and server. Workstation is by the default one. That's going to be more user friendly. It's not going to be as obtrusive as a server garbage collection, so it's going to be a little bit more. It's going to be a little bit more suited to UI type things, basically, or any real, user experience type things. Server one. So if you have if you have a long running process, and that's all it does, you may tune this to use server garbage collection if you see that it suits your needs better depending on what you're doing. There's other things you can mess with, but there's just one obvious thing that you can do. But again, if you do change that, you'll have to rebuild and then restart your application. So there's a couple things that you can probably mess with. You'll hear people say, use structs over classes in .NET, but the answer to that is really, it depends. It depends on when you should use a struct versus a class, because a struct is going to be a value type. But if you have enough data on that struct repeated over enough times, you're going to overflow the stack. Whereas a class, that's going to be a value or a reference type. So that's going to be stored on the heap with the pointer on the stack. And so that's going to be taken care of by garbage collection, whereas a struct would not be done so in the same way. So that advice to just to arbitrarily use structs over classes, it really comes down to it depends. Data points that are very small, like you'll commonly see examples of structs with like mathematical things like maybe coordinates or things like that. That makes sense because those are all primitive types. The ints and then the struct itself, those things make sense. But anything that has a lot of data, or really anything with strings, I really think that those should still be classes because of how they're going to be handled on the heap. And so .NET's garbage collection really it affords us a lot of luxuries. One, you really don't have to worry about allocation and deallocation all that much, unless you're just doing like weird stuff, unless you're working with like strings in some way like that, unless you're working with files, maybe you're working with large text files where you may be using memory streams, which in that case you may need to consider using some form of object pooling. .NET provides a recyclable memory stream for that purpose, where it basically doesn't. It's not going to go and allocate all this new memory. It's going to use what's already been allocated. It's going to recycle that, so you're not going to leak data. So it really depends what you're doing. Again, if you're working with large text files, you're going to need to do that. If you're working with strings, you're probably going to want to use String Builder. If you're working with anything that holds a connection or implements iDisposable, you're going to probably want to use a using statement. So that way those resources are disposed. And if they're not disposed inside, let's say you're not using a using statement, um, if you have a block set up like a try catch or something like that, add a finally to the bottom of that and make sure that's always released, because if you leave hanging connections, that's just going to create a leak. And iDisposable has to be implemented correctly, especially if it's manually. So you need to remove that connection. And so you should probably place that in a finally block if you can't switch that to use a using. So there's a couple things there, but that'll get you pretty far in terms of memory, working with memory in .NET. But that counter tool is very powerful, and it doesn't matter if you're in VS Code, Rider, Visual Studio. You can pull up this and have it running on the side and really very quickly identify, hey, is my endpoint, did I create a memory leak? Another thing to consider is that, using um, properties versus local variables, there's some memory implications there. But I mean, if you're not working with big data sets, you still need to be cognizant of memory leaks. It might be harder to identify, but if you're working with large data sets, it's going to be a little. You're going to see it. I feel like a little faster. But honestly, working with smaller data sets, and then just over time, there might be a leak. Or maybe you're working in a distributed system with users and things like that. So just when you're in code reviews, just be mindful of like red flags when it comes to you know how much memory are we allocating, or how many variables are we creating. Should this be a local variable? Should this be a field? Should we work with classes or structs? Do we need a using? Does this implement iDisposable? Uh, what's another one? Um, are we setting this back to null when it's done with? Things like that. Just try to be looking for those things, because I feel like those are going to generate good conversations too, in terms of learning and just talking about your overall system's performance. So hopefully this was helpful, and I'll see you in the next one.